Hey there, Myers Mathematics, where I'm here to empower you to achieve your goals in life and in school, and to eliminate mathematics as a stumbling block so that you can develop a plan for long-term success. I'm Mr. Kyle, and today we're going to talk about how to graph a point, right? Really kind of a simple topic, but just wanted to kind of really explain because this is the foundation of everything else that you do that has to do with this graph. Everything else has to come from graphing a point. You cannot solve a problem with graph, right? With the XY axis here, as we're gonna, talk about in a second, unless you know how to graph a point. So very potentially simple, very much so potentially an issue if you don't get it. You've got to start somewhere, right? So let me make sure I have the right color here. Okay, so I'm going to start off with black. The the coordinate grid, right? So this is just ignore this, right? Obviously, if you're working on paper, you have paper, so we don't need to focus on that. But the coordinate grid, right? So coordinate. If you're familiar with Call of Duty, right? I know a lot of you guys and gals are playing that new Call of Duty app and getting those kill death ratios up. So, good for you. But you've probably done a co-op, right? You're cooperative, right? You're working together. So coordinate, like working with, um, that means that the y is working with the x, right? That's how you can remember it, right? X working with y, right? Like co-op, like cooperative, which is what co-op means when you play Call of Duty. Co-op, right? So the x is working with the y in order for you to graph a point, right? That's the whole point. No pun intended. And then grid is just the name of what we. It's just the name. It's just the name of the result, right? So the name of the result of x working with y is a grid. That's the title. That's all that is. All right. Another way to say it is the xy axis or the Cartesian plane. If you're looking at a textbook and you've been trying to read the textbook or read the notes or read the notes that you took from the teacher or whatever, and you see Cartesian plane, it's just a fancy name. All right, plane isn't the thing that flies around in the air when it comes to mathematics, unless you're working on a word problem, and then it could be. But plane, Plane, all right, so plane, Cartesian plane, just real quick here, Cartesian plane. If you have a plane, it just means it's 2D. So really like all the shapes, right? Like circles and squares and triangles and stuff, they're all planes. They're all what's called plane figures. Plane. They're 2D figures. That's all that means. So it's two-dimensional, right? And it's really hard to, go 3D and 4D, and it just gets exponentially more difficult as you go up in dimensions. Um, because you're working with paper, which is essentially 2D. So plane just means 2D. Cartesian actually comes from the guy who invented this, right? So he's dead. You can't go kick him. His name is Rene Descartes. Descartes. It looks like Descartes, but I think the S is silent because he's like French or something. Um, so Cartesian, Descartes. That's where the name Cartesian comes from. He invented it. Um, it's thought that he invented it because of like streets and stuff. Like he was in a city one day and he was like, "Oh, look at this! Like streets kind of go like up and down, and then like the avenues kind of go like left and right. So maybe I can like do something with that and torture all the kids to come for generations and generations." And that's what he was thinking. He was thinking of you specifically, you right now watching this video, and how he's going to torture you with mathematics. Just kidding. Um, but really though, so coordinate grid, Cartesian plane, there's a couple different titles, um, but it doesn't matter too much what it's called. It doesn't really matter that much. So here's why, right? Y goes up and down, right? It goes up and down. I have no idea why Y is like that. I guess it doesn't really matter which one is which necessarily. It's just standard procedure, right? So X, right? So X, which goes left and right. So if you're going left and right, you have X. If you're going up and down, you have Y. Um, the one way to remember it actually is like Y is kind of like a longer letter, right? It kind of goes up and down, like the part of the Y that has the tail here, right? That goes up and down. I mean, more or less. It's like at an angle, but it's the long letter out of the two. And then X is left and right. It's the shorter letter out of the two. Um, so it's not the long one, it's the short one. So it goes left and right. It's a fat little kid. I don't know. Just whatever helps you to remember which one is which. But basically, you always start off with your X, right? So you start off with your X, and then you end with Y, right? And the reason why is for this one, it's because it's, I don't know, alphabetical order, right? So the way to remember that is it's in alphabetical order. Alphabetical, right? If you say all your ABCs, eventually you get to XYZ, which also, fun fact, means that your zipper's down. So if you've ever heard somebody say XYZ, and then you were wondering why they were quoting letters to you, it's probably because your fly was down, and you're welcome. Now you know. So X comma Y, that's all this is. That's all this boils down to. This whole topic of how to graph a point, it all boils down to X comma Y. That's the trick. Okay. So now, now we need to know where to start. Okay. You always start right here. Right? This is where we start. Right? So this is where we start. And now that I'm writing in the second quadrant over here, fun fact, there's 4 quadrants. We'll get into that in a second, but let me go ahead and label them. Since I'm already talking about it, I might as well go ahead and put labels on them. So the thing where everything's positive is the first quadrant. That's where you start, and then you kind of just go around in a circle and name them all with Roman numerals, and that's how you normally do it, right? So quadrant 1 is where everything's positive. Quadrant 2, quadrant 3, quadrant 4. I'll come back to those later. But we need to know where to start, right? So we start here. We start here at the point, because anywhere where you start, right? If I were to start somewhere else, it wouldn't matter because it would have a point, right? So I start where there is no point. Right? This is where there's not really a point. But so if I wanted to call it something, besides it looking like a little smiley face, well, no, I guess he's not smiling. He's just kind of like staring at you, right? 0, 0 looks like a little face that's staring at you, like a little ghost person. But we have to start somewhere, right? So why not 0? That's where, um, you know, nothing's really going on, right? If you have 0 of something, then you don't really have anything, right? There's nothing going on. So the start is at 0, 0, and it's called, right? It's called the origin, right? Like an origin story, right? Like the Joker movie that just came out. It's his origin story. It's important. You have to start from there, right? It's his origin. You start from the origin, and then they might make some more movies about the Joker later on, or they'll just keep randomly placing Joker in future movies like they've been doing for the past years now, where it's all about Batman and then Joker kind of shows up, or it's all about his girlfriend and then he kind of shows up. But you have to start somewhere, right? So why not the origin? Why not 0, 0? So that's just why. It's just why not? That's really no other reason. And then once you know where to start, right? 0, 0, aka the origin, aka where the x and the y axis meet, right? So when I put y and x, I didn't put axis, y axis, meaning line, right? It's the line. Axis is a fancy name for line. So axis, x-axis, aka the x line. The line where like all of the x values are housed, right? Or at least the ones that we label. So the x-axis, the y-axis, where they meet is the origin. That's where we start. Okay, so now we need to know where to travel, where to go to. Okay, so there's two different ways to do this. I can either give you a point, and then you can find out like what it is, right? So if I just put a point somewhere, let's say right here, and I'll be nice and put it, right in between some clean numbers and not give you any decimals or fractions or anything. But if I want to get to this point, right? So I start here. I need to get here. Okay, I can't just go straight towards that point, right? So knowing that you have to start from the origin, going to that point, you can't just go straight towards it. Not yet. There's another system where you can go straight from the origin to the point, and it's actually something called polar coordinates. But that's a whole different story, whole different topic, right? We can't just go straight towards the point, right? That's not how this system works. The system works by you going left and right, and then up and down. All right. So the other way that I can do the other way that I can do this. Let's just say it like that, I guess. The other way that I can do this is I can move this way, right? This way. So I'll say this is red. So this is red for x. I can move this way, and then I can go this way. And since I've said x is, moving left and right, then I can say that left is negative and right is positive. That way I know which one is which. If I just say I'm going to go right 4 and I just put the number 4, well, what if I go left by 4? That's still 4. If I move left 4 spaces, that's still 4 spaces. So I need to create negative numbers. So the negative numbers here are only just telling me the direction that I'm moving in. That's all they're doing. They're just telling me the direction that I'm moving in. So if it's negative, I move left, and if it's positive, I move right. So that's all the negatives do, is they just differentiate which direction I'm going. Right? So I'm going to move, if I say this, right, then this is 4, positive 4. I have to move positive 4 spaces, meaning right 4 spaces. So I went right 4, right by 4, and then I'm here, right? So I'm not done yet because I haven't gotten to my ending goal, but I'm here. So from here, I go up, right? I go up by 1, 2, 3, 4, 5, 6. Up 6, so positive 6. And that's it, right? I'm done. I found the point. It's 4, 6. Okay, let's do another one. So let's say I want to go over here, right here, right? So this time I'm not going to do all the fancy colors. I'm just going to go straight for it, okay? I'm not going to go down or up. You go X first and then Y. So I'm going to move left or right and then up or down. In this case, I'm going to go 1, 2, 3, 4, 5, 6, 7. 7. Actually, I'm going to move this 7 a little closer to the point. 7, comma, 1, 2, down. 2 down, right? So 2 down is still 2, but since I'm going down, I'm calling that negative so that I know which direction I'm going in. Okay, so if you move down, you call it negative. If you move up, you call it positive. If you move left, that's negative. If you move right, that's positive. Okay, and if you forget, normally the grid is always labeled with these numbers on it, right? So if you look here, right, that's a -1, so that's down from the origin. And over here, that's a -1, so that's left from the origin. Anything left or down is negative. Anything up or right is positive. That's how it works. Okay. Now, what if I gave you a point? What if I gave you a point and then I told you to find out where that point is? So let's say -3, comma, -4. Okay. How would you do that? Well, first you have to remember that it's always going to be x and then y, right? Which means that I'm going to go left or right, and then I'm going to go up or down, right? That's what that means. X always goes left or right, and then Y always goes up or down. It never changes. It's always true. So we just need to figure out which way. Well, I already told you earlier, right, that if you have a negative, it either means left or down, right? So left is negative, right is positive, up is positive, down is negative. Well, I have two negative numbers, right? So that means that I'm going to go left and then I'm going to go down. I'm going to move left and then I'm going to move down. And I'm going to do that by 3 spaces and then by 4 spaces. So I'm going to go left 3 and down 4, right? That's exactly, this is what this translates to, okay? So this translates to this. Okay, -3, comma 4. When you read that, what you're thinking is, okay, -3 is x, -4 is y, x goes left or right, y goes up or down, -3 means I'm moving left, -4 means I'm moving down, so I'm going to go left, right? It's negative, and I didn't mean to say left, right. So I'm going to move left because it's negative, and I'm going to move left by 3, right? So -3, left 3, comma, okay, -4. Okay, so -4, negative means down for y, right? 4 is a y value. So I'm going to move down because it's negative by 4 spaces. So that's what you do. You go left 3 and down 4. Okay, so let's do that. All right, where do we start? We always start at the same place, right? Always start at the same place. Okay, the only exception is when you're using slope to find the next point, right? Then you don't start at the origin, right? Once you've plotted a point and you're trying to find the next point using the slope, then you go from that point to the next point, right? So that's the only exception to that. Anytime you're plotting a point, you use the origin as your start. If you're plotting another point from a point, like if you're dealing with slope, right? If you're trying to use slope, then you don't start at the origin. Excuse me. Unless, of course, the point, there actually exists a point on a line that is at the origin, and then that would be a different story. But -3, -4 means I go left 3, 1, 2, 3, and then I'm going to go down 4, 1, 2, 3, 4, right here, -3, -4, right? That's it. All right, let's do one more. So negative, let's see if I can make one fit in here. Let's do -2, comma 7. Okay, so x, y, meaning I'm going to go left or right, and then up or down. Okay. Left is negative, right? I have -2, so I'm going to go left because it's negative, left 2, and then comma, right? So actually, you can kind of think of the comma as like a separation of two different directions. The -2 is telling you to do something, and then you take a break, and then you do the next thing, right? So this is telling you to do something. So do something. Then the arrow here, right, is like saying take a break. And then the last number is do another something. I'm sorry, it's a little sloppy. But So do something, right? The first number, do something, right? Move left or right. Take a break, do another something. It's two directions. You go left or right and then up or down. So -2, left 2, and then it's 7. It doesn't say positive or negative, it just says 7. Well, if it doesn't say negative, you assume it's positive, right? You assume it's positive. If it doesn't have a plus sign in front of it, you assume it's positive. So it's +7, which means I go up 7. Okay, left 2, up 7. All right, let's do it. Left 2, up 7. Here we go. So left 2, let me change color so I don't get it confused here. Left 2, right? 1, 2, 1, 2, 3, 4, 5, 6, 7. Right here. So this point right here is -2, comma 7. Okay, and that's pretty much it. That's how you plot points. Is you either start with the point and you travel to it, or you start with the numbers and you use those as directions for your travel. Okay, so the last thing to wrap this up is these coordinates, not coordinates, the quadrants. Okay, and if you've ever heard a word like that, like quads, right? Quadrilateral, your quadriceps, right? If you're a gym buff, you know what quadriceps are. Hopefully you're working out those quadriceps in the gym. Don't skip leg day, all right? And then if you know about quadrilaterals from, a previous math class or maybe this one, um, that means that it's a four-sided shape, right? Like usually a square or rectangle or whatever. Well, quadrant means the same thing. Quadrant, right? So quad means 4. And I'm not sure what rant means. Rant is kind of what I'm doing right now. I'm ranting. Just kidding. It's quadrant. There's 4 places, right? So you can say this is places maybe. 4 places or zones or planes, right? Plane meaning 2D. So there's 4. If you kind of let the x and y axes chop up your grid, it chops it up into 4 quadrants, right? 4 sections, right? So here's one right here, right? So um, right, so this right here, that all of that, right? It's not just a square, right? It's a, I mean it's technically kind of a square, kind of a rectangle. I don't know. It goes on infinitely, right? So it's not really a shape. It just goes on infinitely in the up direction and the right direction. It's really really big. Then you have the second quadrant, right? So then the second quadrant goes from here to here. So it's everything that's up and to the left. Anything that goes to the left and up is in the second quadrant. And then you've got the third quadrant, right? So anything that goes left and down. Anything that goes left and down. And then lastly, anything that goes right. Anything that goes right and down. There's only 4 different ways to hash this out, right? So either you go left or right, 2 options there, and then you either go up or down, 2 options there. Well, 2 times 2 is 4, last I checked, right? 2 plus 2 is not fish, it's 4. So there's 4 total options, right? The number's either going to be, negative or positive, and then it's either going to be negative or positive again, ignoring, zeros, of course, because if it's 0, comma something or something comma 0, it's technically not in a quadrant. It's on the line. So there's kind of 5 places, I guess, that that a point can go. It can go in one of the 4 quadrants, or it can go on the x-axis or y-axis, or both. Right? The point 0, comma 0 is on the x-axis and the y-axis, since that's the one place where they cross. But I digress. You're probably getting bored. So 4 quadrants. Whenever you see that, they're saying something's in some quadrant, that's what they mean. Okay. Um, Not really sure why they decided to put quadrant 1 top right. I'm thinking because it's, it's all positive, so you want to start with being really, really positive. That's all I got with that one. And then I especially don't have any idea why they chose to go, left and then down and then right and then back up, as opposed to like, going diagonal and then up and then diagonal again or whatever. I don't know, but that's the direction they chose to go. Um, so you just got to deal with it, unfortunately. But that's how the quadrants go. Top right is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. All right, y'all. This has been Mr. Kyle at Myers Mathematics. Hey, by the way, I have a free PDF that I'd like to give you. Something you can kind of just stick in your pocket and have as a little note. It's a guide on how to never miss a math mistake. Okay, so if you've ever missed a math problem, which is pretty much anyone ever, and you would think like, oh no, Einstein never got a problem wrong. No, he got more problems wrong on his math than you ever did. And I don't mean that to take a shot at you or be rude or anything. He he did so much math that he got the problems wrong a lot until he tried to figure out a way to do it right. That's a whole nother story for another time. Sorry, I'm ranting again. But um, so I want you to be able to solve any math problem and never make another math mistake. Okay? There are some tips and tricks, specifically 5 things that I focus on in my PDF that I want you to have for free. You can go to my website, myersmathematics.com, and on the page there, you can click on the link, and I will deliver that PDF to you so that you can have a shot at never missing a math problem ever again. Okay, I want to send that to you. Um, and hope that it serves you as well as it should, and what the title suggests. So go ahead and check that out. Download that on my website, myersmathematics.com. And until next time.